Okay, in this video, I'm going to talk briefly on how these two things are related to logarithms and exponentials. Log is just short for logarithms, in case you see that. Pretty much, these are inverses of each other. So go ahead and write that here. These are inverses of each other. So that means that when you're solving especially, you can use, if you're solving like a logarithm, you can rewrite it as an exponential to get, like, kind of like to cancel the log to solve for x. Okay, so the first examples I'm going to do are just going to be rewriting, which is pretty easy. Kind of follows this little pattern here and this little pattern here. And then after that, I'll do a few that are just solving. Okay, so before you start anything, you might want to write all this down. So pause the video if you need to. There's a full screen of it, and you have to excuse my voice. I'm a little sick, so forgive me for that. So go ahead and write this down, and I'm going to start with this one right here and show you how to rewrite this one as an exponential, okay? So zooming in here on the logarithm, we have log base b of x is equal to y. Now there's a note here that says you always start with the base. So the base of this one is my b, okay? So if I'm going to write this as a logarithm, I'm pretty much going to get rid of the log. So to do that, I start with my b, and it would be right here. So b, okay? And then if you look at the little diagram up here, it just kind of goes around in a circle. So b to the power of whatever's over here. So b to the power of y equals, and then it just goes around again to x. So equals x. And that's it. That's the answer for this one. That's how you rewrite this as an exponential. And if you look up here, that's exactly what I have over here. Okay? So now I'm going to do the same thing, but I'm going to jump to the other side. So let's say I have an exponential. I want to write that as a logarithm. Well, now that you're going to do a logarithm, you do have to start with the word log. Okay, so there's that word log. And I'm going to start with the base again. So there's my b. And the base would be this tiny little b right here. Okay, hopefully it's not as blurry as it's looking for me right now. And you go around, so b to the power of whatever's over here. So that x goes in parentheses, equals, come back around, y. And that's it. And if you look again at the diagram, it's the same thing. So we have b goes around, x goes around, y. And that would be my answer for this one. Okay, that's a parentheses, just in case you were wondering. Okay, so I'm going to use this to do a few more examples. And like I said, these shouldn't be too hard. It's when we start solving that it gets a little bit tricky. So let's do another example. Let's try, for instance, I don't know, log, I'm just kind of making these up, 3x is equal to y. Okay, so if I want to rewrite this one as an exponential, again, you start with the base, so with that 3, so 3, okay, we come around, so to the power of y, and we come around, is equal to x. And that's it. Something a little bit more, not difficult, but maybe just weird looking. Let's throw a fraction in there. So let's say you have log base 289 of 17 is equal to 1/2. Okay, we do the same thing. So we're going to start with our base. So that's going to be 289. And it comes around, so to the power of 1/2. Okay, equals 17. That's it. Okay, so that's pretty much rewriting logarithms into exponentials. I'm going to go to the other side and do a few examples with the exponential. So now we're going from this form to this form, okay? So let's say, for instance, we have something like 9 to the negative 2, and I'm just going to throw negatives in there because why not, is equal to 1 over 8. Okay, so this has a negative and a fraction. So don't freak out. Remember that we're writing this as a logarithm. So that's going to be, start with the word log. Okay, start with our base. So this is the base, the 9. So it's log base 9. And I meant to do the opposite color here. Sorry about that. It comes around. So in parentheses, we have the 1 over 8. Okay, equals, and it goes around, negative 2. So this is your answer. Okay, don't let those parentheses freak you out. Sometimes it won't look like that. It'll look like this: log base 9, 1 over 8 is equal to negative 2, and that's the same thing. I like to put the parentheses just to kind of separate that this is the base and that's something else. Okay, so these two are the same. Don't let that mess you up. Okay, let's do one more of these and then I'll go ahead and jump into the solving. Trying to go a little faster as requested by the class, certain individuals. And if it is too fast, you can always pause it and go back. You can ask me in class as well if I'm available. Okay, so let's look at another example. Let's do 7 to the power of x is equal to 2401. Okay, so we're writing this as a logarithm. So again, we're going to start with the word log. Start with the base, which is 7. So log base 7. Okay, come around. So 2401, remember the parentheses is optional on this part, is equal to x. Okay, that's it. Because we're just dealing with individual numbers, like, 2401 is an integer, x is just one entity. That's why I can get away with the parentheses or not parentheses. But later on, we'll see that you do have to put parentheses in certain cases. Okay. So yeah, that's it. That's rewriting logarithms using the inverse property. Okay, so on the other side of this paper, I'm going to go ahead and do some solving. If you want to like kind of subtitle it maybe, so your notes, you can leave it the same notes, just maybe put like a little thing that says we're going to be solving now. So we're going to be solving, let me see, logarithms using exponentials. And I'm just going to put a little bubble around that. It's kind of like a subtopic, okay? So for this one, what I'm going to do is I'm going to just kind of start with an example and show you how we would use the rewriting concept to solve something. So let's say you have log base 3 of 81 is equal to x. Okay, now if you had a calculator, you could just plug it in, of course, but we're trying to do this without a calculator. So what I'm going to do is I'm going to rewrite this as an exponential. So I'm going to go from my base, so 3, so there's my base, go around to the power of x, and go around. Okay, so it's equal to 81. Okay, now this is a little bit of review from Algebra 2. When you were solving exponential equations, there was this rule that says that for you to solve something like this, the bases have to be the same. So in other words, this 3 right here, so this 3 should be the same as this 81. Now obviously these are not the same. The one's a 3, one's an 81, but we can rewrite one of them in terms of 3, okay? So I'm going to go ahead and kind of go to the side over here and make a note here. We're going to rewrite 81 in terms of 3. Okay, that's the trick for this. Now, some people are really good at this and they can tell me right away that 81 is the same as 3 to the 4th power. But if you're not, if you're, like me, kind of have to break it down. here's what I would do. Okay, I would take 81, and I'm going to still use the side over here. So I would say, actually, no, let me do it here because my paper's moving. So I know that 81 is 9 times 9. Okay, but that's still not a 3. I need this and this to match. So I have to break it down even more. So this is 3 times 3. And this is also 3 times 3. Okay, and so you see how now we have a bunch of 3's. So I'm going to go ahead and rewrite that as 3 to the 4th power because there's 1, 2, 3, 4 of them. Okay, so 3 to the 4th power is the same as that 81. Do you see that? So I'm going to rewrite my equation with this instead. So I'm going to have 3 to the x is equal to 3 to the 4th. Okay, and now that I have same bases, so now that I have my b's right here are the same, you can kind of like think of it as crossing it out. So I can take these bases out and just look at the top. And so now x is just equal to 4. That's it. That's how you solve one of these, okay? Now this is real basic because there's only one letter and one number. It can get more complicated. For instance, let's say I'm just going to kind of make this one up. Let's say I had 2 to the power of x is equal to, let's do something kind of simple. Let's do 8 to the power of x plus 1. I'm kind of teaching you a little bit of exponentials, but that's okay. So obviously, again, the bases are different. So I'm going to have to change this 8 right here, okay? So I'm going to go over here to the side and do my little math. 8 is the same as 4 times 2. I know that 4 is 2 times 2. Bring this 2 down. I'm just breaking it down, okay? And there's that 2 that I wanted. This is the same as 2 to the 3rd power. Okay, so I'm going to replace this 8 with this 2 to the 3rd. So this would now be, let me use the purple one. So 2 to the x is equal to, instead of 8, I'm going to use what I found over here. So 2 to the 3rd power. But since I have more things up here, all that has to go kind of like inside of parentheses, like so. Okay. And then you would just solve it normally. So I would cross these out and I would look at my x's. So x is equal to 3 times x plus 1. Yeah, and then you would just solve it normally. Okay, so I'm not going to show you that part because this is just solving like with algebra 1. Okay, so that's how you would solve something like that though. Okay, so let me do one more that has to do with the logarithms. That way you don't freak out when you see one. Okay, let me see. And I'm using your assignment today to kind of pick and choose the problems that I want. Let's do this one. So log base 3 of 1 over 243 is equal to x. Okay, so now this one's a little bit difficult because we have that fraction. Okay, so before I even do anything, I'm gonna, rewrite it. That's the first step. You want to rewrite everything as an exponential. So here's my 3, there's my base, 3 to the power of x is equal to all this, 1 over 243. Okay, now this is a little bit problematic because we have a base that, first of all, the bases aren't the same. So 3 is not the same as 243. And the other problem is that it's a fraction. So what I'm going to do next, I'm going to flip this. So we did talk about this before. If I want to put this thing on the top, okay, I have to change the power. So this is the same as 243 to the power of 1, okay? But if I flip it, if I put this up here, well, now it's going to be to the negative 1. So 3 to the x is equal to 243 to the power of negative 1. So the power changes, okay? And now that I have this, now I can do the same trick I did before. I can look at my 243, okay, and write that in terms of a 3. So I'm going to go ahead and do that over here on the side because I'm out of room. So 243, let's see, what's divisible by that? I'm going to say 3 times, let me see. You have to do some math on the side, that's fine. This is called division, in case you didn't know. Okay, so that's going to be 8, 24, 0, 3. 3 into 3 is 1. So 81. Looks like it's 81. Okay, so 3 times 81 is 243. Okay, I can break down the 81 to 9 times 9. Just going to keep bringing that 3 down. I can break down the 9 to 3 times 3, and this one to 3 times 3, and then just bring down that last 3. So it looks like I have 1, 2, 3, 4, 5 3s. So this is the same as 3 to the 5th power. Okay, so I'm going to replace this one with my 243. So now my new equation, I'm almost out of space here, is 3 to the x is equal to 3 to the 5th power. Okay, and then there's still that negative 1 right there. So I just replaced this 243 with this. Okay, so just like before, I can go ahead and cross out my 3's. And I'm just left with x is equal to, so x right here is equal to 5 times negative 1, which is just negative 5. And that's it. That is my answer. So hopefully this helps. Let me know if you have any questions in class and I can come help you out.